Okay. So a very good evening to all of you. First of all, I would like to publicly express my gratitude towards Professor Narendra Mohan for accepting the invitation in such a short period of time. Professor Ned Mohan completed his BTech from IIT Kharagpur in the year 1967. He holds two MS degree, one from the University of New York in Dublin and another from the University of Wisconsin Madison Square in nuclear engineering. He has completed his PhD from the University of Wisconsin in the year 1973 under the able guidance of Professor Holland A. Peterson. He has authored more than 80 transaction papers, 20 patents, and 250 conference proceedings. He has also authored many well-known books on power electronics and types. In the year 2019, he has been honored with Regents Professor at the University of Minnesota. He was also elected the National Academy of Engineering in the year 2014. He has received the prestigious IEEE Narayanji Hingorani Award in facts for his contribution in the year 2014. He has also been elected as an Oscar A. Scott Professor of Electronics and Systems. So, ladies and gentlemen, please welcome Professor Harendra Mohan from the University of Minnesota. Over to you, sir. So, your voice is not audible, sir. Hello? Sir, your voice is not coming, sir. Yes, sir, now. Hello? Sir, your voice is not coming, sir.
Okay, is it coming now?
Yes, sir.
Okay,
Now,
yeah. I had it was muted. So first of all, thank you very much, Professor Shantanu Chatterjee, for inviting me and for
thank you.
this kind introduction. And I would say that you organized this workshop on an extremely timely topic because I think electric vehicles are our future. So, I don't particularly do research in electric vehicles as such, but my research is on integration of utility scale renewables to the grid. Okay, and the interface, power electronic interface between that. So in that sense, we also work on electric vehicles because electric vehicles, if they take off, they will be supplied by higher voltages than we normally think of, and therefore there are different type of topologies that may be needed for that. So I think it's a very timely topic, and there are two students I had made offers to come here as an RA, but they did not come here because they had another opportunities where there's a lot more electric vehicle research is going on. Okay, so I think I sincerely congratulate you on your choice of the topic and also the number of eminent speakers you have lined up in this
Thank you, sir.
workshop. So I wish every success to you and to your audience and your students. So could you give me a little bit of background? Where are you located exactly?
Sir, we are in Arunachal Pradesh, sir. Arunachal Pradesh.
Okay. Uh, so, so this is an NIT.
Yes,
So
sir.
NITs are very prestigious institutes, as I understand, in India. Okay. I have had several students from NITs. So I think, I hope your audience gets excited and you don't know what these young people would eventually come up with, right? So the presentation that I'm going to give you is on power electronics education, not so much on research. And this education is always the foundation, the starting point, and therefore, we need to pay attention, and we also need to give hands-on education. So we have been developing laboratories which go along with these courses, and are in these courses, and we are trying to make them as affordable as possible, and so more and more universities can then acquire them. So one recent laboratory experiments we developed on electric motor drives, I think that has been acquired. Many kits were acquired by an Indian university. I forget the name, some private Indian university in Bangalore. Okay, so I think there's a possibility of providing this education, which is a very hands-on. Okay, so we should not forget that. And then we just have to look at the recent trends and continue doing research, and whatever happens afterwards. Right? We don't control that, but that's really my pitch. Shantanu, should I say anything else that you like me to say?
Thank you, sir. Thank you for being present over here.
Yeah.
That you are a very busy person, and in spite of your hectic schedule, you have consented to come over here, sir. Thank
Yeah.
you.
Sure,
Yes,
sure. No, I like to. Someday I like to visit you in person at
yes, sir, yes,
at your
definitely,
university. Yeah,
definitely, sir. Yes, sir.
yeah, yeah, yeah.
Okay. So now,
So
yes, sir. So
yeah, go ahead.
this is now I will like to play a video which Professor Sir has given to me. Okay, and after the play of the video, after the end of the video, the participants are free to ask questions to Head Mohan Sir. Okay, because he will be present at the end also. Okay, so let me allow Sir to play the video now. Okay, sir.
Sure.
Okay, okay, sir.
Everyone, I'd like to welcome you all to this presentation. I'd like to begin by thanking the organizers to include me, and I hope, I wish, I should say, that we could have met in person.
So I feel the video
It
is
was not going to be.
feasible to you. I feel the recording is
There is a
feasible to
chance
you,
that
isn't it?
some kind of yeah, it is. It is visible to me.
Yes, sir. But external noises are coming, sir.
Available
I
to
think somebody is having the two devices on.
let's get
A
started.
lot of echo is there.
Very brief introduction. My name is Narendra Mohan. So Narendra is a name that you probably all. Shantanu,
Yes, sir. Yes, sir.
I log off so there's no disturbance, and then I'll log back in 40 minutes.
Yes, sir. Yes, sir. Yes, sir. Thank you, sir.
Okay.
Yes, sir.
Sure.
Yes, sir. Thank you very much. Thank you.
Yeah.
Sir, please unmute the mic.
There is no audio.
Can
Sir is not audible. Sir.
It's not audible.
Okay, okay. Just let me see.
While playing audio, you have to have audio on the right side. There are three options. It is the third option open. Go to Shantanu.
Yes, 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 yes.
So you have to play audio. No, there are options on the right side. You have to play third option for the audio and motion.
Fine,
on.
fine. So, and how is it audible? Now is it audible?
No. I think when you play audio, no, before you play video, on,
Ah.
right, on the top right side, there is an option before you play video. The third option is there, audio in motion. That has to be on. Then we can listen to audio. Before you play the audio, there a setting is there. Yeah, right side you can go to audio, go to the video. At right hand top right corner there is supposed to be 3 options right before playing it. The third option you set it. No sharing.
Share also.
Go to sharing on the right side on top. There is supposed to be one option.
Share it as
স্যার হচ্ছে তো অডিওটা আসছে কি
দেখো অঙ্ক অঙ্ক অঙ্ক
There are 3 options are there on top with the no sharing.
And I hope, I wish, I should say, that we could have met in person, but that was not meant to be. But the good
I
news
look
that
at here.
there is any is that some kind of vaccine is around the corner, and hopefully it becomes available to all of us everywhere soon. So let's get started with a very brief introduction. My name is
স্যার আপনি গুগল মিট থেকে শেয়ার না করে ডাইরেক্ট ওয়েবএক্স থেকে শেয়ার করলে আমার মনে হয় বেটার অডিও শোনা যাবে। গুগল মিট থেকে শেয়ার করছেন যেটা মনে হচ্ছে, তো আপনি স্যার যদি সিসকো ওয়েবএক্স থেকে ডাইরেক্ট শেয়ার করেন তাহলে আমার মনে হয় বেটার সাউন্ড কোয়ালিটি আরো ভালো আমরা শুনতে পাবো।
if it was today.
আসছিল আসছিল
Hello, everyone. I'd like to welcome you all to this presentation. I'd like to begin by thanking the organizers to include me. And I hope, I wish, I should say, that we could have met in person, but that was not meant to be. But the good news, I guess, if there is any, is that some kind of vaccine is around the corner, and hopefully it becomes available to us everywhere soon. So let's get started with a very brief introduction. My name is Narendra Mohan. So Narendra is a name that you probably all are familiar with, but my Americanized name is Ned, and that happened long ago. And if it was today, it may have been a little different. But anyway, that's the name I'm stuck with, Ned Mohan. So let's get started with that brief introduction of mine, that I'm at the University of Minnesota, and this is my 44th year of teaching. So what I would like to share with you are some of the slides that I have prepared. And, I would say that probably you are all very familiar with them, but let's just sort of review them in a way. So let me get started here, and I'm using Zoom, and I hope I'm able to do it properly, and I'll also hope that I'm being recorded here. All right, so the topic of the presentation that I have is Power Engineering Education in the Age of Climate Crisis, a holistic view. What you see here is a kind of a shot, of our campus. The river Mississippi flows right through it. So it's a beautiful campus, at least in summertime. In wintertime, it's quite a bit covered with snow. And then at the bottom, you see my email address. In case you want to reach me, please feel free to do so. All right, so with that little bit of background, let's go to the next slide here. I always start my lectures by showing this slide here, that it kind of puts humility into context, that, and there is nothing new actually. The greatest accomplishment of 20th century science has been the discovery of human ignorance. So that's Dr. Lewis Thomas. He was a physician and also a medical writer. And similarly, this is philosopher emperor on the left. He's talking about everything we hear is an opinion, not a fact. Everything we see is a perspective, not the truth. Well, I would say there's an exception. Climate crisis is not an opinion. If you believe in science, it's a fact. All right, so let's leave it at that. And then, so you know, this electricity is basically a basic human right. Okay, I grew up in Jabalpur, which is in Madhya Pradesh, and you know, I used to travel with my father to small towns where there was no electricity. Okay, so it was then, and I didn't realize how serious it was. But today, now that we are used to electricity, I think it's basically a human right issue that you know, so many people, as you see in the slide, according to United Nations, 1.3 billion people are without any access to electricity. So, you know, this link that you see at the bottom of this slide is a presentation by Rajiv Shah. Rajiv Shah is the president of the Rockefeller Foundation, okay? And he talks about energy poverty, you know, what it means, for example, in Bihar, where he traveled to. And he has teamed up with Tata, and you're all familiar with Tata Electric, about $1.5 billion to $1 billion project to bring electricity to villages using photovoltaic. So I really urge you to take a look at this link in the first half an hour of it, where he is talking. All right. So climate change. Well, there's not much doubt at this stage that climate change is happening, and it's basically happening because of our activities. So we had organized a workshop in 2017 where Dr. Gavin Schmidt, who's the director of a NASA institute, and this NASA institute is called Institute for Space Studies, okay? Institute for Space Studies. So he is a modeler and a predictor, okay? And he gave a presentation very convincing as I have ever seen. And he talks about how, you know, climate has changed from pre-industrial age, about 1 degree centigrade, which is about 2 degrees Fahrenheit, okay? And he talks about that it took only 4 degrees centigrade to bring about ice age. So we have already gone roughly 1/4 of ice age in the other direction. And you know, you have heard of this Paris Accord of 2015 and how it will limit temperature rise to 2 degrees centigrade, perhaps 1.5 degrees centigrade. So, you know, all these things are very important to at least delay the catastrophes ahead, if not totally avert them, because what we have already done to the planet. All right, so this is what, so I'll go back to the previous slide. I'll urge you to look at this web link here is half an hour presentation. You can download from this link. All right, so he talks about that in, you know, in the worst scenario, if we keep doing what we are doing, the picture that you see is on the right lower hand corner, where our climate would ultimately become that of Venus, and life as we know it would be impossible. And aggressive mitigation he has totally ruled out because that should have begun yesterday, and even now there is no accord as such between countries. So he just hopeful is the serious mitigation, which you see on the middle, on the upper side, and even there he says that there will be portions of the globe where temperatures would reach as high as 4 degrees centigrade, which he said is a full ice age unit in the opposite direction. So these are pretty scary predictions, and these are for year 2100. But not that everything would be rosy until December 30th of 2099, and just certainly things would change in year 2100. Things would, if you don't do something, things would slide towards that catastrophic event or events. All right, so what do we have? Well, we are technology people, and technology is essential. And there we have basically two options to reduce our carbon emission. One is to use wind, and the other is to use solar. So here, our National Renewable Energy Lab has done some life cycle analysis, and they tell us that compared to coal, which produces 1,000 grams, 1 kilogram of CO2 equivalent for every kilowatt hour of generation of electricity. Okay, so compared to that, wind is 10 grams, which is 100 times cleaner, and then solar is 40 grams, so that is 25 times cleaner. So this is life cycle analysis from cradle to grave type of things, right? So at least they have made an attempt to include everything. All right, so now the good news is that the cost of these renewables has been going down. So here is a chart that is produced by this Lazard Associates. That's a very often quoted website, at least in the United States. And so whatever I'm presenting to you is sort of US-centric because I don't have much information on a worldwide basis. So these slides that I have put together are, pulling information out of US sources. So you see here that coal and gas, they are, 52 and $65 per megawatt hour, whereas solar and wind are quite a bit cheaper, 32 for wind and 43 for solar, right? So that is why a lot of utilities, not that they are all that interested, well, they may be interested, I shouldn't say that. They're interested in the climate and the environment because it will affect us all. But they are, in the short run, interested in the bottom line. Okay, so if solar and wind are cheaper, then why not use coal? Why not use them as compared to gas and coal? But the rooftop solar, putting solar panels on the roof, they are still very expensive. So that's an area where a lot of research can be done to bring down the cost. Okay, so that's a good news. And so the answer is that, first of all, we should shift all our energy use, wherever we use energy, to shift it to electricity as much as possible. And then generate that electricity from renewables like wind and solar, all right? And then conservation, which is kind of a missing piece. We don't often think about conservation, at least in the US, and that is very important, because any electricity we don't use is not going to produce any greenhouse gas. And then we have to develop a sustainability mindset. Wherever we can reduce our energy, electricity consumption, we should do that. But at the end, we also have to realize that the science alone cannot stop global warming. Our human attitudes must change, okay? But, so what technology we are talking about here is essential, is totally essential, but not sufficient. These human attitudes must change, okay? So here is a picture that I took from this book by Varun Sivaram, and there's a web link given here. That book, where is it? I had it here somewhere in front of you. I don't see it. So I just found it here. So if I could put it in front of my face, you can see this book, I hope. It's called Taming the Sun. Taming the Sun. Okay, so he's really, tremendous young man who has done so much in his, such a short period. And what he shows at the left here is value versus cost for installed capacity. So as the penetration of these renewables increases, which is plotted on the horizontal axis, you see what's happening to cost and value. Okay, and you can see that cost is declining, shown in red, and the value is declining, also shown in blue. And you can see that there is a crossover at a certain installed capacity. And why is value decreasing as the installed capacity increases? Well, the reason is that, as you well know, that these renewables are variable, they're intermittent. The wind always doesn't blow and sun always doesn't shine. Okay, so because of that reason, and the batteries are still expensive, and therefore the value goes down as the installed capacity increases. And you can see the crossover point on the slide on the left. But if you reduce the cost, okay, of these renewables, and that's where the challenge for us is, to continuously keep reducing the cost of these renewables. So if we reduce the cost, new cost is shown in solid red line in the middle picture. And you can see that then the crossover happens at a larger installed capacity. But then the slide on the right, a picture on the right shows that if we keep on decreasing the cost as well as some systemic innovations that he talks about, and you can look at the meaning of that, then the crossover may never happen. Okay, you can keep installing more and more renewables. Okay, so that's what we see on the right here. All right, so we have a long way to go. Okay, so here are the figures for the electricity generated in the United States in 2018. And in 2019, you can look it up going to this link shown below. And what is showing us is that wind and solar were a very small part of this total electricity that was generated in the United States. So photovoltaic was only 1.5%, and the wind was only 6.6%. So if you look at it on a global basis, and you'll see that it's even smaller on a global basis. Okay, so we have a long, long way to go. But, so we should get started on this. And in doing so, we should really take a holistic view, okay? Because the world is not compartmentalized into power electronics, electric drives, and control. All these things are, taken together to build up a system. And so we should look at it in a holistic way, how we generate electricity, how we transmit that electricity, and how ultimately it's used in the end. So, obviously we should, generate it using renewables. We should transmit it as efficiently as possible, and then of course conserve. And then we should also look at applications and use for transportation. Okay, we'll talk about transportation. Okay, and defense, that's important, as well as industrial competitiveness, like automation, robotics, advanced manufacturing, and so on. Okay, so take a holistic view. Okay, so for wind, we know how the system looks like. We have these towers, and in the nacelle, at the top of these towers, we have the blades, we have a gearbox, we have a generator, and that generator runs at variable speed depending upon the wind speed and how fast these blades are rotating. And then this variable frequency, variable amplitude voltage, and current, that power comes down the cables and this may be 100 meters tall tower, and at the base of these towers is a power electronics converter, which converts a variable frequency, variable amplitude AC to, let's say, 690 volts and 60 hertz that we use in this country, voltages and currents. And then at the base of the tower, there's another transformer which boosts us up to 34.5 kV. And so that has become a de facto collection grid voltage at which hundreds of wind turbines in a wind plant may be connected. Then all that power is aggregated, and there's another transformer there that transfers 34.5 kV to and boosts us up to 161 kV. Okay, and then it's transmitted over transmission lines. Okay, so you can see that here we are using, of course, mechanical concepts, but then also electric machines and drives. That is in the machine is in the nacelle above ground, and then you have power electronics converter, then you have transformers and the transmission line. So they all make up this whole system, including, and then control. Control is very important, and also how these turbines should operate under fault conditions, so-called zero voltage right through. Okay, so all those things are sort of, all in one system. Okay, so that's why we need to take a comprehensive look on this education. Okay, and same thing with solar. You have a picture of this Topaz solar plant in Southern California. It's a 550 megawatt plant. It's spread over a large area, and so in the bottom left, you see the sort of a schematic of how power is collected from all these photovoltaic panels, how it's converted to AC to a power electronics converter. Then there are transformers to haul it away to wherever the loads may be. But also, I mentioned to you about rooftop solar. So that's where there's a lot of potential. This National Renewable Energy Lab is telling us that 40% of our electricity we can generate through rooftop solar. Because the solar roofs, the roofs are already there. We just have to put up these solar panels. But the cost of those installations are still pretty high. Okay, so hopefully, as time goes by, those costs come down. All right. So we also need storage, because we talked about how these solar and wind resources are variable. So here is a slide in green. You see what wind is doing as a function of time, but these red dots you see, they indicate what wind was generating when the demand was the highest on the utility, on the system. Okay, so they are kind of they are not correlated at all, right? Because wind was producing very little when the demand was highest. Okay, not always the case. And if you have diversity, you can reduce this picture, this anomaly. So it clearly indicates the need for storage. Okay, so that is kind of a missing link at this time. And but a lot of research is going on in making these batteries cheaper and more efficient. Okay, and on the right here, you see what we call a duck curve. So this is kind of what is happening in California, and what you see here is the load demand on the utility as a function of time in a given day. And you can see that when the sun is shining and photovoltaics is producing a lot of power, the demand on the utility system goes down around the noon hour. And then as evening approaches, people are getting home, turning on their appliances, and the sun is going down, so therefore the demand on the utility system ramps up. Okay, demand from the utility system ramps up, and you can see there's a tremendous ramp that these utilities generators need to have to meet that demand. Okay, so that's again a problem that could be somewhat reduced by having storage. Then in terms of transmission, there has been a talk of this high voltage DC grid. So that's still in the planning, and who knows whether it'll ever come about, because what it'll do is kind of introduce diversity. So throughout the entire country, for example, it will take the resources from wind and solar and put it on this grid. And so some places where sun is not shining, in other places it may be shining, and similarly about wind. So it can make use of that diversity. All right. So again, I like to point out one part which is often overlooked is the role of electric machines in drives, okay, for this type of application. So, we know that we need these drives for generating power from wind plants, wind turbines, but we also need them for electric transportation, right? And we'll talk about transportation. So those are the two major applications that we can think about. And talking about transportation, in the United States, the carbon footprint of transportation has exceeded that of in the electric power sector. And this crossover happened somewhere in 2016. So transportation, which is, by and large, almost by using gasoline, petroleum, so that has to change to electric, okay, if you're going to get rid of this greenhouse gas emissions in transportation, okay. So, these electric cars are coming, and still a very little penetration in the United States, and so you can see a charger here, and we had played a role. It didn't go too far because what we had developed was for charging of electric vehicles that General Motors was producing at that time in the mid-1990s. So there's something called Minnesota Rectifier, which our university had patented. And it was used to charge a fleet of cars, not individual electric vehicles, but a fleet of cars. But then General Motors, they were leasing these electric cars called EV1, and they thought that there was no money to be made. So they, took back all those cars, and they were shredded in California desert. So there's a movie called Who Killed the Electric Car? If you get some time, please take a look. So then the unfortunate part, and I think it's happening probably everywhere, the enrollments in the electrical engineering programs are dropping, okay, whereas they are increasing in these trendy areas like, they're important too, like AI and machine learning and big data. But these electrical engineering programs, like what we are talking about here, they are equally important. So here is the history of electric energy curriculum and how it was in the decline, where these courses have not changed over a long period of time. And so that needs to change. So I'll not read through all the bullets here, but now power engineering is seen as critical to growth and sustainability. So we need to rethink the curriculum, okay? So, I'm sorry, I went the other way. So the proposed approach we have is first to design a pipeline course from where, by which we can entice, attract students from high school to come to in this curriculum, and then give them very solid information by few carefully designed undergraduate courses, and then have graduate courses that may be shared with colleagues across the country, and they could be online. So I'd like to talk to you about all of them. Okay. So this is a pipeline course we have developed. Last time we taught in fall of 2019, we had 111 students. Okay. So, it could be a very popular course. It could be taught on a university-wide basis, because in this course, you don't even need to have a physics background, high school physics background. Whatever physics is needed, we teach it. So here's the website here, and I'll urge you to take a look at the structure of this course. So we have very high hopes going forward with this course here. So like I mentioned to you, this course can also be taught in high schools. And if high school students take this course, they get university credits in addition to satisfying their high school requirements. Okay, so it's called dual credit concurrent enrollment program. Okay, so right now we are teaching this in only 5 high schools in Minnesota, but there are about 500 high schools, and maybe 20 in Minnesota alone. And if you multiply that 50, Minnesota being an average size state, there could be 2,500 high schools. I don't even know how many high schools there may be in India, for example. Lot more. Okay. So we really need to look at this electric power engineering curriculum in a holistic manner. And this, when we say power, this includes power systems, power electronics, electric machines and drives, as well as controls. So what we did at our university, that of course we have core courses in the middle that all students, whether they're going into power, all students have to take them, like circuits and some basic controls. But then we designed very carefully 3 courses, one in power electronics, one in electric drives, and one in power systems. And these are standalone courses, and students can take any combination of those. And that allowed us to have these complementary courses before they graduate. Because our feeling was that undergraduate is not necessarily for specializing in any one particular area. Some focus, but not totally specializing, but rather to have a broad-based education. So when they graduate, they can choose to go in whatever field they may wish to. But still, you have to have a little bit of emphasis in one particular area. So in this case, the area we are talking about is power. Okay. So this slide, I kind of shaded it out, where it shows that we had, our enrollments in these courses almost tripled. Because of privacy, I shaded it out, but from 15 or 20, it went as high as 90 students in one semester. So to accomplish that, our group has been writing textbooks. On the left, you see this power electronics textbook. It was, I think this date may be wrong. It was, I think, 2003. So this number here, maybe I can change it right here. I think this number was 2003 when the 3rd edition came out. And then there are some subsequent books which are basically tailored for undergraduate courses. One is on power electronics, other one is electric machines and drives, and the third one is on advanced electric drives, which is for a graduate level course. So what my postdoc Siddharth Raju and I did was to take all these 3 books and combine them into a sort of one single book, which just came out in August of this year, and this is on analysis and control of electric drives. Okay, so the unique aspect of this is that it has simulations in a platform that was developed here called Workbench, and if you simulate using that platform, then you can seamlessly control a hardware laboratory. So I'll talk about it a little bit in a minute. Okay. So we have this website called CUS, and the URL for that website is at the bottom. And so all the material that we're developing, we're uploading onto this website, and it's totally free to download for anybody. Okay, you don't even have to become a member. But 235 U.S. universities have become members. You know, I don't think at the moment anyway there is any benefit to becoming a member, because all the material that we have can be downloaded by anyone without becoming a member. But we are hoping that at some point, through these members, we have some further development that we can upload to this website. All right. So we have developed 17 senior and graduate level courses, and you can see the breakdown here in power systems, power electronics, electric machines and drives, and renewable energy. Okay. So, you know, we have been using this material quite a bit in the courses that we are teaching here at our university. And then I'd like to talk to you about, in the time remaining, about these hardware labs that we have developed. So this development started almost 15 to 20 years ago, and approximately, actually, we know these numbers pretty well. About 109 U.S. universities have acquired these hardware laboratories. But they have been getting old, right? They were developed 15 years ago, so if components break down, it's very hard to find these legacy components. So we have been very fortunate that through a 4-year grant from our Office of Naval Research, which is a part of the U.S. Navy, we are developing new laboratories which are wide bandgap based, extremely low cost compared to what we had in the past, and you know, they are digitally controlled. So here's a picture of a drives laboratory, electric drives, and so this before going to the lab, I should say that we could use you know, these materials that we have developed for online master's degree program. And here is a you know, simulation platform picture, and then the hardware that can be controlled if you do your simulations in this platform that which we have developed. It's very much like MATLAB Simulink, but it's totally free. Okay, MATLAB Simulink is not free. Okay, whereas this is totally free. And if you simulate your system using this platform, then you know, controlling these laboratories and the you know, these hardware laboratories is seamless. Okay, so a little bit of description of what this platform looks like, and as you can see, not all that different from MATLAB Simulink if you're used to it. And here is the setup for induction motor vector control. So not only you can control and you know, characterize these induction machines like in an undergraduate course, but you can also use them for vector control that is often taught in a graduate course. Okay, and so what this simulation would look like for this vector control, and the results would be like, let's say you want to change the speed from one level to another, how you can go to it very fast, and that can only be done if you're using vector control. Okay, and then some results here I'll skip over. All right, and then also for permanent magnet synchronous machines. Okay, so the whole kit here is very low cost, and that is what's shown in this slide here. Okay, so this was the previously used system we were using, and the cost comes out to be, you know, $40,000 for non-academic and about $20,000 for academic purposes. But these laboratories that we have designed and we have been using them now are extremely low cost. Perhaps a factor of 5 they are maybe more. Look at here. The total cost here is $3,000, right? And so compared to $20,000 in the previous setup, this is about 7 times cheaper here. And so this is what an electric drive kit looks like. It comes in this box. It has, DC motors, and then it has a current magnet synchronous machine, an induction machine here, and then and this inverter board, which is described here in more detail. So it uses a very low-cost TI DSP, which is on board over here. Okay, and so this has been a tremendous success for us, and you can see the experiments that can be conducted in the basic drives lab and then advanced power drives lab. So before that, using the old setup, we were never able to do, these advanced experiments like vector control. But all those are now possible using this drive laboratory we have. Similarly, we have a laboratory for, and this is again using wide bandgap devices and digitally controlled, and we can control this laboratory to do all these experiments that are listed here. Okay, and that was again not possible with the laboratory. Only probably 1/3 of these could have been done in our previous laboratory in power electronics, but now they are all possible here. And then we have dreams of extending that for power system emulation. Okay, so you see here that each card can emulate, because this is happening in real time. It can emulate a PV system on the left, and it can emulate a grid on the right, and interconnect the two. So in a microgrid, for example, we can emulate 5 nodes, some of them generating power and some of them consuming power, right? And only the losses need to come from a DC power supply. So this is at a pretty low voltage of 40 volts. We are just trying to make students understand the concepts, right? So 40 volts, so very low cost, but it gives all the concepts that needed to be explained, right? So here are the list of experiments. Because of the time, I will not read through them. Okay, and so the other beautiful unique point, I should say, of these laboratories is that they can be controlled remotely. Okay, remote control. Okay, so here I made up this picture like a cartoon. Okay, so let's say you have a power electronics laboratory, and you just need one setup. Okay, and usually in a laboratory you have 5 or 10 setups, right? We don't need that. We just need one setup. Okay, and because they are digitally controlled, they can be controlled through the internet. Okay, so let's say in week number 3, you have an experiment on flyback converters. When you can set up this thing for a flyback converter, and students can then have a timesheet where they sign up for a 2-hour slot. So you see here the student on the upper left, he or she has signed up for a time slot from 2 a.m. to 4 a.m. Okay, I know students work 24/7, right? So no, I'm just joking, but any time of the day or evening or night, a student can sign up for this 2 hours time slot, and then other students can sign up for other time slots. And then every week, the instructor or the teaching assistant can change the experiment from flyback converters to, boost converters or whatever, right? So the point I'm trying to make is that it becomes cheaper by another factor of 5 or 10, because for 30 students, let's say, you just need one setup. So that's so imagine that for $2,300, you can set up the entire laboratory course. So also, this postdoc Siddharth Raju, he has developed a general purpose prototyping platform, which is very low cost, and it can be used for research purposes. So we are using it in many research projects that we have. I don't have time to talk about those, but they can all be utilizing these. And these laboratories could also be used for, doing some research projects at a very low power and low voltage level before they go into, before students build their prototype at high voltages and higher power. Okay, so the contact information of Dr. Siddharth Raju can be found on this website that I have listed here. Let me just click on here just to show you what this website looks like. And you just go to this website and it has product information. So it's really a University of Minnesota startup. Okay, and just for the record, I have zero financial interest in this startup here. My role really is to disseminate this information that is available for you to use. Okay. So let me go back to these slides here. So I must acknowledge this grant we have from Office of Naval Research, which has allowed all these things for us to happen. And the goal of this grant was really dissemination, not just to make this development happen at University of Minnesota, but promote it nationwide, in fact, worldwide. There's no restriction. Okay, so I'm coming to the last slide here. That we are on this. We are a speck on a speck, which is circling around this middle-aged star we call the sun, and there are 200 billion such stars in our galaxy, the Milky Way, and there, scientists are telling us, observational astronomy is telling us that there may be over a trillion galaxies. But anyway, the bottom line is that this is the planet we have, and there is no planet B, like they say, plan B, right? There is no planet B. And this Professor Carl Sagan says there is no hint that help will come from elsewhere to save us from ourselves. So true, so true. So thank you very much. I hope I did some justice to this presentation. Any comments or questions you have, I'll be very glad to entertain them. So once again, thank you very much. Bye-bye.
So participants, do you have any questions? You can ask, Professor. Sir is now present with us.
Morning, sir. So very good morning. This is Chandrasekhar from Kongu Engineering College. Are you able to see me, sir?
Sir, why is it not coming, sir?
Sir? Are you able to hear me, sir?
Yeah, I can hear you. Again, I don't know why it goes to mute, but you can hear me probably now, right?
I have one small question, sir.
Okay.
So we most of the electrical engineers don't have a model of electrical house or electrical vehicles in our life. Which factor or parameter struggle us to develop this one?
Yeah, that I couldn't fully understand that question because of the interference. Could you please repeat it?
So most of our electrical engineers don't have the model as their own home or their own vehicle as an electrical one. Which parameter makes us to hesitate this one?
Again, I'm sorry. Maybe it's my hearing. which is going, but you're talking about that you are electrical engineers and you have something, but you don't have something else. But I could not understand what that is. Shantanu, are you there?
Yes, sir. Yes, sir. Yes, sir. I'm there, sir. I'm there, sir.
Maybe your connection is better than your participants. So if you could repeat the questions, I'll appreciate it.
Even I also couldn't understand, sir. Actually, so even I
Uh,
also couldn't understand what he's trying to say, sir.
yeah, okay. Well, in that
Anyone else?
case, he can send me an email and I can answer it. So,
Yes. So, anyone
sure.
else on the participants? Please. Dear participants, do you have any questions? Please ask.
Hello.
Send here live.
Good evening, sir. I'm
Yeah,
Dr. Siddharth Subhasachi.
hi,
My doubt is, so you are talking about the education system, but
right.
in nowadays in Indian universities, so many vast new courses are coming, and they are ignoring the basic fundamental course, and they are adopting the new course. So how will deal with that one?
Yeah, no, I think that's somewhat of a universal problem. Okay, and so
But
it's not only in
that is okay,
Indian.
but the students will suffer because when new courses will come, the university is doing, they are removing the old courses and they're adding that one. So how
So
students will, so as a teacher, how will guide the students to go ahead in that area?
yeah, I think that's a very valid question. And as I mentioned to you, that it's kind of a universal problem, and we need to deal with it. So I think new courses are coming, and let them be coming, but that's probably to attract students. But in guise of those new courses, we can still teach them the fundamentals. So we can say that this course, let's say, is on you know electric drives and for sustainability. Well, what that would mean that we use electric drives for windmills, and we're also using electric drives for electric vehicles. But in the context of that, we can teach what needs to be taught. For example, basic principles of electric machines, how they work, and then how with power electronics they can be controlled in speed, right? By varying the voltage and the frequency of that voltage, how that electric machine can become an electric drive to operate at different speeds. And that's what you need in wind turbines. That's what you need in electric vehicles. So that's something which we have done, is that we have tried to, change the title of the course to make it more attractable, so to speak. And then, we fulfill whatever the title says, but also talk about the fundamentals. So that'll be my suggestion to not uh, not try to fight this introduction of new courses, but modify those courses such that they include the fundamentals. Yeah,
Thank you.
so that's
Thank you, sir.
sure.
Hello.
Anyone else?
Hello, sir.
Yeah, hi, Khalid.
Yeah, this is Dr. Khalid Imran from Vidyavardha College of Engineering, Mysore, Karnataka.
Nice. Okay, good
Yeah,
to talk to you.
yeah, same here, sir. Same here. So, what courses do you search for mechanical engineering? So, for mechanical engineering students, what are the courses which are advisable?
See, mechanical engineering students
Yeah.
should know about how to integrate power, renewables into the utility grid. They should also know a little bit about power electronics, uh, in general, but also, a lot of mechanical engineers nowadays are also transitioning to electric vehicles because we are replacing internal combustion engines. So it could be you can make a course. In fact, my former postdoc, now he is an assistant professor at NIT. No, actually it's not NIT. I'm sorry, IIT Harvard. IIT Harvard. And together we are writing a book which kind of gives an sort of a holistic view of power, so-called power, which includes power systems, which includes power electronics, and which includes electric machines and drives and their control. So I think that would be a very good course for just in one semester course. Mechanical engineers could get a pretty upper level view, so to speak. You cannot go too deep down, but it will be useful for that. So that's my suggestion.
Thank you very much, sir. Thank you very much.
Sure.
Sir, good evening, sir. I am Dr. K. Umar Living, sir. Sengundara Engineering College I'm working, sir.
Okay.
I'm having one doubt, sir. After completing a PhD, I want to do PDF, sir. Which area is essential? Now is advanced is there, sir? PDF.
Yeah, right. Yeah. So, Madevi, good to be talking to you.
Yes.
Did you say you're in civil engineering?
No, sir, I am tripling, sir. Electrical and electronics engineering, sir.
Okay. I'm sorry. I misheard. So, yeah. So, and you want to do postdoc fellowship? I think.
Yes, sir. Yes, sir.
There's no. I would just suggest that you do your. It will be based on your research, obviously, for your PhD research.
Yes, sir.
And whatever PhD is, have you picked the topic for your PhD research yet?
Yes, sir. Finite element method using BLDC motor, sir.
Okay. So,
Torque improvement, sir.
Okay. So I think, what you have to do is to, PDF usually requires some forward-looking topic, which could
Okay, sir.
eventually be used in industry. So, if you can tailor your research, you could, do whatever to, convince anybody who has the funding and the opportunity to offer you postdoc fellowship sees the value in what you can contribute. So
one of our participants have asked a question to you, sir.
Okay.
Could you please tell the advantages and application of induction machine vector control and PMSM vector control, PMSM machine-based vector control drive?
So, if you're going to control these machines, whether they are induction machines or whether they are synchronous machines, they have to be vector controlled, okay? Because otherwise, the model is very complicated and you cannot get a very good response, like torque response to increase speed or keep the speed constant or whatever. So the vector control is the only way to go, and that field-oriented control or vector control, as it is called, is, the principle is the same, whether you have induction machine or you have a, permanent magnet AC or synchronous machine, right? So it's the same, and both of these machines are used. So, for example, Tesla is using both machines, and they don't describe the details as to why they're using it and how they are used in the driving cycle, but they even said in the advertisement dual motors. So they're using two motors, one induction and one synchronous. So they are trying to synchronous meaning brushless DC, or quite often called PMAC, permanent magnet AC, right? So they are using the best characteristics of both, depending upon the the driving range they have, right? So I would say that both are equally important. As when it comes to DC motors, by and large, DC motors are not being used in electric vehicle electric vehicles, which is the topic of this workshop. But I think to know about electric DC machines is important also. I mean, because when we do vector control, we are basically trying to emulate a DC machine. Okay, so we need to know about DC machines. So that's really my comment to what you asked about these two machines. Thank you.
Another one has asked, sir, you mentioned about a software which is similar to MATLAB. What is its name?
Okay, its name is Symbol Workbench. So Workbench, there are a lot of other softwares that are named Workbench, but this one is developed by Siddharth Raju, my postdoc, who has started this company, Symbol. So it's called Symbol Workbench. So that's the name of that software, and it's totally free to download and to use. Okay, and that is the software that is needed if you're going to control a drive, for example, right? So you have drive and hardware with power electronics and with machines, and then some, software is needed to control that. So using his software, you totally remove the need for the MATLAB Simulink, for example, if you're thinking of using that. And you cannot use MATLAB and Simulink to directly control these machines. There's an interface that is needed, which could be quite expensive. So basically, the need for that interface also disappears. Okay, so directly from the software in which you can model your machine, and then seamlessly you can go to control that machine.
Another wouldn't have asked, sir, what is the importance machine learning and AI in today's industrial development? What is the importance in machine learning and AI in today's industrial development?
Okay, so I know as much as probably okay, because I'm not an expert on it. My research is not on it, but machine learning is important, right? In some sense, it's not the only thing, but by machine learning, you know what can happen, right? And how you can best utilize your system. Okay, so just to give you an example for machine learning, and I have a PhD student whose research is somewhat beyond me, but we are looking for a co-advisor on machine learning. Okay, and so what he's doing is, he's trying to elongate the lifetime of these inverters, power electronic inverters, used in photovoltaic applications. So, when they are not needed to be operated at their maximum power point, because maybe there's a surplus of power, whatever, you could operate them at perhaps lower voltages and lower power levels, and in such a way that the life expectancy of capacitors that are used and the semiconductor devices you have there is lengthened. So I think that's just one example of machine learning I know, and that you kind of that information comes from other sources which are used in this developing this control. Okay, so that's a kind of machine learning. And then AI is everywhere. I don't personally have any special input into it, but wherever we could use these systems in a more efficient manner in overall way, well, that's part of the artificial intelligence. But I better not say anything about that because I don't know anything more about it. So I'll stop there. Yeah. So other questions?
So, anyone else? So another student asked, sir, why the carbon footprints is lesser in wind system compared to the solar?
Yeah, I think that's a very good question. Well, the reason for a smaller footprint of wind turbines versus photovoltaics, I think it probably has to do with the manufacturing process. Okay, and because I think you have to compare the same power rating, actually, not power, energy output, kilowatt hours. So how much carbon is produced to get, let's say, 1 kilowatt hour. Okay, so that could be the unit through which you compare these two. So, what I would suggest is that if you want to know in detail why is that the case, we have this National Renewable Energy Lab, and NREL we call it, and they have this so-called life cycle analysis. So cradle to grave. So you also have to dispose of them at the end of their life, which may be 20 years, 30 years, whatever, right? Wind turbines seem to have a longer lifetime than photovoltaic. Maybe that's one of the reasons that the carbon footprint for wind is smaller, right? So what I would say that you please take a look at those reports, and that may be very meaningful. So.
Anyone else from the participant side? Please ask.
Hello, sir.
Hello.
Sir, I am Shudip Chaudhary. Sir, I am going to ask a silly question, sir. I have known that the electric vehicle should be very much costly. So the country like us in India, where there is not so much rich people here, so it is exactly feasible for us to do some research or do some setup in here for the electric vehicle.
Well, Sudeep, I'm not sure how to answer that question either, but what I would say that in the long run, electric vehicles, so what are electric vehicles? Other than just an electric machine and its control and batteries, okay? So electric machines have been around forever, and I think their cost is not likely to go down, okay, very much. The power electronics cost may go down, but also, not, well, it can go down depending upon the topology and so forth. But I think the biggest advancement will come in batteries. Okay, so right now we use lithium-ion batteries, and there's a lot of research going on. And lithium-ion batteries today, they have a liquid electrolyte. Okay, and it has certain disadvantages like catching fire, and you cannot charge and discharge very rapidly, and energy density, things like that. I mean, they're good, but we want to make them better, and at the same time reduce the cost. So a lot of companies are doing research on solid state lithium-ion batteries. Let's not call it lithium-ion batteries, solid state batteries, where the electrolyte itself is solid. Okay, and so that has advantages and simultaneous advantages in all the areas I mentioned. The hazard of fire is less, the energy density is higher, charge and discharge charge rate is higher, and the cost may also be less. So I think those are the things, and but at the same time, you have to realize that electric vehicles should really operate from electricity that is produced through renewables.
Okay,
Okay.
sir. That should be
Otherwise,
possible. But sir,
Huh?
if you use supercapacitor, what I have learned from some research paper, supercapacitor is such advantageous or not advantageous, sir?
Supercapacitors, you know, a lot of hype has been there, but supercapacitors, as far as I know, they are very good for rapid charge and discharge. Okay?
Yes, yes, sir.
But they don't have the energy density. So, you know, how are you going to replace batteries by supercapacitors? So that is a challenge, and nobody has an answer for that. And that's why all
Some
the
Chinese are doing some research on that, but they are at some advanced position. But I don't know exactly what is they are doing. Just I have to ask that it is feasible or it is advantageous to use the supercapacitor instead of the battery, sir.
you know, from my knowledge, what I'll say is that supercapacitors cannot replace batteries as they exist. If there's some breakthrough, then it's possible. But if there is no such breakthrough, right now, supercapacitors could only be used if they are used. They're not being used as far as I know.
Yes,
but
yes, sir.
it's in combination of batteries, where for fast and charge and discharge, you can use supercapacitors, but for energy density and based on energy density, for energy, it's the batteries.
Okay, sir. Thank you, sir.
Sure.
I'm Amit Kumar Mittal. I'm Chief Engineer in Military Engineer Services. First of all, sir, congratulate you for such a wonderful session. It was really wonderful for us.
Yeah, thank you.
I have got one question, rather, I have got one suggestion.
Sure.
Whatever alternate technology we are looking into, it must be assessed on life cycle based.
Yeah.
Like we are going for electric vehicles. Now, for electric vehicles, you have to create an infrastructure.
Right.
Okay. And spread over large area where there will be a lot of losses in electric supply itself. And then electric generation is normally, even now today, 70% of the generation is creating a lot of global warming. So my suggestion is that whatever alternative we are developing, whether it is hydrogen, whether it is fuel cell, whether it is electric vehicle, we cannot call all these methods like, kind of very energy efficient or very nature eco-friendly till the whole of the cycle is eco-friendly, right from the generation of the electric supply or whatever energy source is there, or even including manufacturing of the equipments, whatever equipments we are manufacturing, we are losing a lot of energy into that. So my point is that every alternate should be basically considered based upon life cycle and then only compared that which alternative is the really sustainable. And then we really need a circular economy. Like there is a problem of disposal of electric batteries and many other components. So all these factors should be combined to have a total environmental impact right from the beginning of the cycle to the end. That's what my point is. Would you like to throw some light on this?
I think you have very well laid out what needs to be done. I'm not sure anything more needs to be added to that. That unless we look at the whole thing from cradle to grave, so you talk about natural gas power plant. Okay, so if you look at just the carbon emission for generating 1 kilowatt hour of electricity by natural gas in a gas plant, that is not a complete answer, right? Like you said, somehow that gas has to get there. From boats, it may come in a liquid form and then transported through pipelines to this natural gas plant, which may be located somewhere else. And what happens when you mine may not be the right word, but when you try to extract natural gas, a lot of methane leaks out. And as you know, methane in extremely short term, like today, if you release methane, is 120 times more potent in terms of global warming.
Correct, sir.
Than
Correct,
carbon
sir.
dioxide, right? So I mean, all those factors are there, and so it's it's a very complicated picture, which needs to be looked at to combat climate change. And in addition, so I think that the technology and engineering has hope. So that's how I present this material to my students. So, if you say it's hopeless, why would they want to listen to me if it's hopeless? But I think from science and technology perspective, and also conservation plays a whole role, a big role. Or we turn off the lights when we are not there, right? That's conservation. And I'm giving a silly example, but that's a factor. So what I'm saying is that what you have said is you have very well laid out the scenario, my friend. Amen.
Right, sir. Thank you so much.
Sure.
Hello, sir.
Hello, sir. This is Ratan Kumar from Chennai, and
Okay.
I was very much happy to see Ned Mohan sir. We used to call him God of Power Electronics when we were in college.
My goodness, my goodness.
So your books, like before studying your books, we need to have basics clear, and after that only we should go to your books. This was my faculty's suggestion always. So very happy to see you virtually, sir, at least. I have a question, sir. Like you said, like your students are switching on from smart grid to EV charging and all. So do you think like in US, the smart grid is getting outdated?
No. I think, see, smart grid from day one was not very well defined. What is a smart grid? Who knows? Who knows?
Correct, sir. Always we keep on adding definitions. Now we have IoT in that, and a lot of addition in that we have seen.
Yeah. No, I think first of all, a grid is just a grid. It's like a network.
Yeah.
Network of roads. You have network of roads, right? But what vehicle you're driving on that on those roads, and under what conditions, and so forth. So of course, the road infrastructure should be very nice, very efficient, so there are no traffic jams and things like that. And similarly, electric grid needs to be like that. So that's smart grid. So I wouldn't say that smart grid is going out. Smart grid is getting perhaps things are being added to it, like you just said, IoT, right? So the things are being added to it, and so smart grid is just a nomenclature. Grid has always been quite smart, okay, but it needs to be made smarter, okay. So how do you connect these, microgrids to the utility? Well, that could be under a smart grid topic, right? And how do you manage the smart grid? How do you load? There's a lot of discussion on load. What is it called? Load management, I think. Load management, where you could do not, I mean, curtail the load when the power demand on the utility is high. They shift it. So let's say during midday the demand is very high. Well, you can shift some of the loads which do not need to be used at that time to evening hours. The reverse may happen if you have a lot of photovoltaic generation. Yeah.
Thank you, sir. Thank you.
Sure.
So one of the participants have asked, sir, would you please explain the low voltage ride-through graph. I couldn't get it. Low voltage ride-through graph in your presentation, sir.
Okay.
Participants, please mute your microphone. Please mute your microphone, please.
Okay, so that my answer to this low voltage write-through or zero voltage write-through is that on the utility system to which these renewables are connected, they are wind plants or power plants, photovoltaic plants, PV plants, to which to the utility grid they're connected, there'll be, disturbances. There could be a short circuit somewhere and the voltage drops drastically, right, of the utility. So what should this inverter-based resource, as we call it, could be batteries actually even, and then wind and photovoltaic. What should these inverter-based resources do? Okay, so what zero voltage right-through or low voltage right-through says that they should remain connected. Okay, and they should provide perhaps reactive power. Okay, to support the voltage if the voltage were to drop. Okay, so there's a standard coming pretty soon, and it's I'm not sure it's IEEE or something else. It's called P as in Pratap, P, 2800, P2800. So you can, Google it, and it's not completely, in the final stage yet, and people still have to vote and may have some objections, but it gives a very good idea as to what the industry globally, in a way, is thinking about this zero voltage and low voltage right-through. Okay. So, that's something these inverters should be designed for, so they remain connected when such disturbances on the utility grid occur.
Anyone else? I feel everyone is satisfied
Sir,
with the
sir, one more
presentation.
question. I'm Amit Kumar Mittal again from Military Engineering Services.
Okay.
What is the latest on charging infrastructure?
Charging infrastructure for electric vehicles?
Yeah. What is the latest?
Well, Biden administration is putting a lot of money as incentives to have these charging stations. And there are some numbers that I don't offhand remember, but you can look that up, you can Google it, that so many charging stations should be there for so many residents in that area. Okay. So because that is the only way to promote electric vehicles, because not having charging stations would mean that people would be reluctant to buy electric vehicles, and if there are no electric vehicles, there'll be no charging stations. So it's a vicious cycle, so to speak. So I think we need to pay attention to that charging station. So that's a challenge. When I talk about electric vehicles, that's a challenge that you need to have plenty of charging stations. Okay.
Sir?
Sir, anything is being done on, sorry. Anything is being done on remote charging, something like that?
Remote charging.
Like I have heard one of the scheme that the things are under research, that the electricity will be generated below the road and then vehicles can be charged. There was some research going on, and vehicle can be charged while moving on the road itself.
Yeah.
And there was another option which I have heard of. That used to be called flash charging. Like within 20 seconds, you charge your battery, something like that. Is it realistic, or it is still in R&D stage?
Okay. So this charging of batteries in 20 seconds, that I have not heard, but I'm very skeptical of that, because these batteries, by their chemistry, have a maximum charge rate. And, and that is also being improved. So that's one of the things may come out with this solid state battery. Okay. So how would you charge in 20 seconds? I'm not so sure, unless something has happened, which I'm not aware of. But in terms of charging where the electricity is underneath the road and it's your induction coupling or something like that, you are charging the battery. But I know that the research going on, and it may be feasible in designated routes. So let's say you have point A to point B, a road where only certain vehicles travel. Okay, and then after from A to B, they go there, and after B, they can go wherever they want. But at least the long distance from A to B could be like that. But that's research is going on, but still, very far off, because you'll have to dig up the whole road, and you will have to then install this electric infrastructure, so vehicles driving on it can extract charge from it. So it's not and research should go on, no doubt, because we don't know what it will lead to at the end. But at the moment, it's not something that we can look, hope to see in, let's say, 10 or 15 years. This is just my crystal ball, where I would say that it would be just, batteries as we know it, but in different forms, improved batteries.
So may I, sir?
Thank you, sir. Thank you so much.
Sure.
May I, sir? I am Sir Dr. Solke from Pune, sir. Like rightly you have said that it is difficult to charge the batteries while in move or when the vehicles are parked, like you're saying, we had a lot of infrastructure wherein you had to have laid the electric cables under the earth, or you had to have the kind of a magnetic line flux kind of a gadget showing the magnetic rays, the batteries cut the line and all. So that is one way of charging the electric batteries. A second option would be, like you have rightly said, and you are also the point where we can have batteries which can be having larger range as such, having by design. One. Secondly, we can, like in the petrol pump, we go and fill petrol, we can share the batteries. Batteries will be charged and kept available for the people to use it. That would be a more viable option. What are the chances of this kind of arrangement more than the having infrastructure to charge the battery while on move?
Well, I already talked about the problems and promise of having charging as you're moving along, because you have the electrical infrastructure, underneath the road. But this idea of batteries being exchanged and being charged, that really never panned out. So I don't know exactly what you're referring to, but I can tell you a story of a company. I don't know what country that technology was promoted from, but it was being looked at here in the US as well. And the idea was that battery exchange. So you drive from point A to point B, and at point B, you can leave your discharged battery, and they will install the charged battery for you within minutes, right? And you're on your way. But that never worked out, because batteries are very strange animals, because their life expectancy depends upon the cycle they have gone through, and the charge and discharge rates and all the other things, right? So, why would somebody take a battery which is about to die and give their good battery, right? So, I mean, that's one of the reasons. And again, I have not done any thorough investigation, but that scheme never came to be. Okay, so that's not an easy scheme. I think for the time being, if you're going to use electric vehicles, I think they'll be battery powered, as we normally understand them, and they will be You have to have infrastructure to charge them, and then also to dispose of these things. Eventually, they will have to be disposed. And a lot of these batteries, which are not very good for electric vehicles because their capacity has diminished, they can be used for stationary applications, like for utility applications, for energy storage. Okay, so so that's the only thing I can think of in the short term. That and also this electricity better be supplied by renewables as much as possible anyway, because if you're generating electricity by coal and then you're using electric vehicles, that may be good in the city where they are being used, right? Because you don't have the pollutants coming from internal combustion engine. However, climate-wise, it will not be good because you're using that electricity that is produced by coal, for example, right? So, there are many issues that need to be looked at, right?
So, thank you, sir. I feel it's the end of today's session because Sir is very much tired, and this flow of questions will never stop. Okay, because it's our dream to have you. Okay, sir.
Oh,
I
thank you.
would like to thank Professor Mohan, sir, to be present here and answer to all our queries. I would also like to thank the participants for their patience and their kind participation. So thank you, sir. Thank you for joining with us. Thank you very, very much, sir.
Yeah, thank you.
Thank you.
Thank you, Shantanu, thank you for inviting me, and thank you for all the participants to listen to me and all the questions I got. And
Yes.
so namaste to all of you, and then we hope to meet sometime in future. God
Yes, sir,
willing.
definitely.
God willing.
Thank you, sir.
Thank you, sir.
Bye.
Thank you very much, sir.
Bye. Bye.
Okay.
All
Bye
the
bye.
best. All the best in your research.
Yes, sir. Yes, sir. Your blessings must be there, sir.
Yeah. Thank you. Bye-bye.
Okay, sir. Thank you.
Thank you, sir. Thank you so much.
Thank you. Thank you. Thank you.
Okay. So, dear participants, thank you for being with us. Thank you for bearing with me.
Thank you, sir.
Evening also, you people attended the session with much enthusiasm. Okay. And it was our pride privilege to have Professor Mohan sir to be with us. Okay. Because he is very much busy with his work. And today also he was very much busy. But still, he, he responded to my request. Okay, so thank you for joining with us. So tomorrow we'll again be joining. Okay, and tomorrow in the morning session we have Professor Akhtar Kalam from the Victoria University. Okay, so hopefully tomorrow also it will be a full packed stadium. Thanks to everyone. Thanks to everyone.
Thank you, sir. Thank you. Thank you very much.
Thank you.
Thank you, sir. Thank you.